Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my beloved students. This time we will learn how to solve the problem related to the entropy. This is the question that we choose for this exercise. If you notice, this question is relatively different from the previous exercise of entropy. A rigid tank contains 8 kg of refrigerant 134A initially at 30 degrees C and 180 kilopascal. The refrigerant is now cooled while being stirred until its pressure drops to 80 kilopascal. Determine the entropy change of the refrigerant during this process. So from this question, we will using the refrigerant property table and some of the pressure drop, and we need to determine the entropy change. This is the recommended step of solution to solve the problem or the question. Firstly, obtain the keyword and assumption from the question. Secondly, determine the properties at state 1 and state 2. And finally, use the equation of entropy change by using the equation of the delta S equal to the M in bracket delta S state 2 over state 1. Step 1, obtain the keyword and assumption. We can jot down the crucial information from the equation by inserting the M equal to the 8 kilogram, referring to the correct property table, refrigerant 134A, with the state 1, temperature 30 degrees C, pressure 180 kilopascal, and determine the entropy. So we also remark the Q is removed from the system. By having this kind of information, we can conclude that the system is the closed system because no information related to the entering or leaving from the mass or mass flow rate. And then we assume to solve this problem by having the specific volume for the state 1 and the state 2 is the same. Otherwise, we cannot resolve or solve this problem. Step 2, determine the properties at state 1 and 2 by referring to the saturated refrigerant table 134A. Okay. And then we referring to the pressure 180 kilopascal at the T set, and we found that the temperature is negative 12.73, and we noticed that from comparing to the equation, T from the equation is greater than the T set at a given P, or 30 degrees C is greater than the negative 12.73 degrees C at a given P, which is 100 kilopascal, 180 kilopascal. Based on this information or requirement, we can conclude that the higher temperature, T greater than T set at given P, is fall in the category of the superheated. And then we need to refer the superheated refrigerant 134A. Next, to solve the property in state 1, we refer the refrigerant 134A in the superheated table, and we can get the answer referring to the P equal to the 0.18 megapascal or 180 kilopascal at the temperature of 30 degrees C equal to the specific volume 0.13248 and the entropy 1.0690. Okay, so this is the information we obtained from the state 1. Next, we need to determine the properties at the state 2. We refer to the property table of saturated refrigerant 134A, and we look at the pressure 80 kilopascal, and we found that the VF and the VG value. Knowing that from the previous information, the V1 specific volume 1 equal to the specific volume 2, and this is the value of the VF and VG, and the V1 or V2 is 0.13248, which is in the range of the VF and VG that we obtained from the saturated refrigerant property table. We can conclude that if the V2 in the range of the VF and VG, it falls in the phase of mixture, so that we need to determine the X or quality. So we are using this equation to obtain the X2. And then we refer with the same property table for SF and SFG value. Next, we apply this equation with the information from the quality and this one, the SF and SFG from the table, and we obtain the answer is 0.553 kilojoule per kilogram Kelvin. Finally, use this equation of entropy change by applying this equation. Delta S equal to the M delta S2 over S1, 8 kilogram from the equation. 0.553 is the calculation that we are performed previously, and 1.0690 is the state 1 from the superheated property table, and we obtain the final answer negative 4.127 kilojoule per Kelvin. This is the question which more or less the same with the previous one. It's just the matter of changing some of the parameters. Hope you guys can try this by your own. So also provide the final answer for you guys to refer with. So thank you very much and all the best.